Hello and welcome to all. Today we will discuss about combination of pulley. This is the diagram of this arrangement in which this pulley is fixed and this one is movable. Here the load is attached with the movable pulley and effort is applied on the fixed pulley, and this is the string which is passed over the both pulley. One end of the string is attached with the ceiling or fixed point, and other at the other end the effort is applied. As we know from the previous lecture that if string is in stressed condition, there is tension is applied all over the length of the string. Here tension is in the opposite to effort, and the load is applied in downward direction, which is represented as L, which is balanced by these two tension. Therefore here load L will be equal to 2T and effort is equal to T. Therefore we can write that mechanical advantage will be equal to load upon effort. From the definition, here load is equal to 2T and effort is equal to T. Therefore mechanical advantage is equal to 2. This is the mechanical advantage if this system is act as ideal system, that is the efficiency of this system is 100%. At this condition mechanical advantage will be equal to 2. For calculation of velocity ratio, if we consider this movable pulley moves upward at a distance x, then the effort end will moves distance 2x, because if this pulley moves upward at a distance x, then at both sides the x distance is loosened, and for tightening the string the effort end must moves to distance 2x. Therefore in this condition the velocity of effort will be 2 times velocity of load, as the displacement of effort end is 2 times the displacement of velocity end. Therefore the velocity of effort end will be equal to 2 times the velocity of load end. Therefore as from the definition of velocity ratio, we know that velocity ratio will be equal to velocity of effort upon velocity of load. Then we have to find out that the velocity ratio for this condition will be 2. This is fixed for this arrangement, but the mechanical advantage is variable, which will be equal to mechanical advantage will be equal to efficiency into velocity ratio. If efficiency is 100%, then mechanical advantage will be velocity ratio. If we consider that the efficiency of this machine is 80%, then we can find out the mechanical advantage for this condition will be equal to, and velocity ratio is constant for this arrangement which is equal to 2, then put the value of efficiency and velocity ratio. Efficiency is 80%, 80 by upon 100 into 2. Here is 8 upon 5, which is calculated as mechanical advantage for this condition is 1.6, which is less than for ideal condition, which is equal to 2. This is the maximum mechanical advantage for ideal condition, that is at this condition efficiency will be 100%. Now we will discuss about the next topic, that is block and tackle system. It is a combination of both fixed and movable pulley. In this system, two blocks, these are known as blocks. This is one blocks and this is another blocks. This is fixed and this is movable. This is a combination of two blocks in which first blocks, which consist of several pulleys. Here in first block, two pulleys are shown, which is fixed with the fixed end, and the other block is consists of one or more movable pulley which is connected to load, and an string is passed over the all of the pulleys. Here string is moves from here, then passed over and attached to the movable pulley with the hooks. Here the string which is passed over all of the pulleys is 1, therefore in whole length of the string there is a tension developed, which is represented here capital T, which is same throughout the length of the string. The one end of the string is the effort end and the other end of the string is attached to the movable pulley with a hook. Here the load is balanced by three segments of the string, this one and this one. Therefore load, here load can be balanced by 3T. Then we can write here L equal to 3T. Load is applied in downward and this tension is acted opposite to the load. Therefore L will be equal to 3T, and at the effort end there is a tension which is acting in opposite to the effort. Therefore here effort will be equal to T. Then we have to find out the mechanical advantage for this system in ideal condition. As we know from the definition that the mechanical advantage is the ratio of load and effort, therefore we can calculate the mechanical advantage for this system, which is equal to 3. Here mechanical advantage is 3 and this is for ideal condition. This is for ideal condition, that is the efficiency of the system will be 100% at this condition. Now we have to calculate the velocity ratio for the system. If we assume that this movable pulley moves upward at distance x in time t, due to this reason the three section of string is loosened by distance x. Therefore the effort end will travel 3x distance. The effort end will travel 3x distance in the same time t. Therefore the velocity of effort will be 3x upon t, and velocity of load will be equal to x upon t. Then from the definition of velocity ratio we know that it is the ratio of velocity of effort upon velocity of load, which will be equal to 3x upon t upon x upon t. This is also equal to 3. Velocity ratio is equal to 3, which is equal to the mechanical advantage of this system in ideal condition. Velocity ratio is fixed for this arrangement, which is equal to 3, and from the definition we know that mechanical advantage will be equal to efficiency into velocity ratio. This is the general formula for all the pulley string system. For this block and tackle system, mechanical advantage is equal to 3 and velocity is equal to 3. If the efficiency of this system is 60%, then we have to calculate the mechanical advantage of the system, which will be equal to velocity ratio is constant, which is 3. Then here mechanical advantage is obtained as 1.8 for this condition if efficiency is 60%, which is smaller to the ideal mechanical advantage for this condition, which is equal to 3. Therefore in different cases we have to find out the mechanical advantage for this system if efficiency will be equal to 90% or 80% or 70%, like that. We can easily calculate the mechanical advantage for different situations. For block and tackle system, there is different combination of pulleys are possible, which is in previous section we have seen that two pulleys are attached with the fixed end and one pulley is attached with the load, which is movable pulley. There are different conditions for the pulley system is possible in this situation. Here is another example for block and tackle system in which three pulleys, the upper three pulleys are attached with the fixed end and lower two pulleys are attached with the load, and a single string which is passed over from here to here to here and connected to the load end of the pulley with the help of hook. Here string is shown with red color, which is passed over all over the pulleys, and one end of the string is attached to the load end, that is movable pulley, with the help of a hook, and the other end of the string is the effort end. Here, because the string is same throughout the system, therefore T is applied in this system on the string. Uh, at the effort end, tension is acted opposite to the effort, and load is balanced by these five segments in which tension is applied. Therefore, in this situation, the load, because the load is balanced by the five segment of the string, then we can write here the load will be equal to 5t and effort will be equal to t. Then we can find out the mechanical advantage. As from the formula of mechanical advantage, we know that mechanical advantage will be equal to L upon E, that is 5t upon t, and mechanical advantage is obtained as 5. This is the maximum value of mechanical advantage, which is for ideal condition or efficiency of the system. Efficiency of the system is 100%. At that situation, mechanical advantage will be equal to 5. If you see the diagram, we observe that there is number of pulley is 5 and the mechanical advantage is also equal to 5. There is a relation between the number of pulleys and mechanical advantage. If the total number of pulleys used in both the blocks is n, both the blocks means the fixed block and the movable block. This section is the fixed block and this is the movable block. In fixed block there is three pulleys which are fixed at this end, and in movable block there is two pulleys which is attached to the load. It is moving and this is fixed. If the total number of pulleys used in both the blocks is n, small n, and the effort is being applied in the downward direction, then the tension in n segment of the string support the load. N segment means here, due to number of pulleys is 5, the segments are 5 which supports the load. Therefore, the number of segment will be equal to the number of pulleys in the system, which is equal to n. Therefore, mechanical advantage will be also equal to n, and this is the maximum value of mechanical advantage for ideal condition, that is the efficiency of the system will be 100%. For calculation of velocity ratio, if the movable end is moved upward with a distance x, then each of the five segment also displaced x distance for tightened string. If this movable block moves upward with a distance x, it loses x distance in each segment. For tightening the string, there is movement of E 5x in downward direction. In this condition, the displacement of if the displacement of load is x, then the displacement of effort end will be 5x. Therefore, the velocity of load is v and velocity of effort will be 5v, which is equal to 5x by t, and this is equal to x by t. Now we have to find out the velocity ratio. From the definition, we know that the velocity ratio is equal to the velocity of effort and velocity of load, which is 5x by t upon x by t, which is equal to 5. Velocity ratio is 5. This is constant for this condition, and the general formula for mechanical advantage is equal to efficiency into velocity ratio. Then in various conditions we have to find out the mechanical advantage for different efficiencies. I will provide the lecture notes for this lecture, and if you have any query you can direct email at amrendra038 @gmail.com.